Hi, today we're going to be doing series, and that's where you add up all the numbers in the sequence. So if you want to try the first two problems, what is the sum of the first 100 numbers, and the other problem, you can pause the video. So my question is, what is the sum of the first 100 numbers? So you could sit here and do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11. I mean, I could keep on going. That would be a little tedious. So we always want to try to do things in a more simpler way, or in a simpler way, excuse me. So let's think about this. If I were to list them all, I would have 1 plus 2 plus 3 plus 4, and then I would keep on going, dot, dot, dot. And if I list the last 5 numbers that I would have at the, or sorry, the last 4 numbers I would have at the end of all these numbers, I would eventually get to 97, 98, 99, and 100. So that's what I'm trying to add up. And again, I can most certainly just add up each individual number one at a time. But I can also remember that adding, I can regroup things and I can add things out of order also, so that it's to my advantage. So one thing we can do is notice this. If I were to take 1, and instead of adding it in a row, if I took 1 and added it with 100, that would equal 101. And then if I added the second number 2, and I pair that up with the second to last number 99, those 2 plus 99 add up to 101. If I were to continue that, 3 and then with 98, those 2 add up to 101. 4 with 97 adds up to 101. And I could continue the pattern. So instead of adding 100 numbers, I really noticed that I don't have to add 100 numbers because I can simplify this. So basically, I know that if I pair them up, each pair is going to multiply or add up to be 101. So basically, the question is, how many pairs am I going to have? Well, 100 numbers, if I pair them up, means I'm going to have 50 pairs. And each of the pairs is going to add up to 101. So basically, I know in the end of all of this, I'm going to have 50 pairs of 101. And to simplify that, it's going to be 50 pairs. Each is 101, so 101 50 times. And that's how easy I can add the first 100 numbers. So the first 100 numbers adds up to 5,050. So as long as this series, the sequence, is going up by an adding number, like this one was going up by 1s, we can actually do this trick all the time. So the next question then will now be a lot simpler. My next question is, what is the sum of all the even numbers from 1 to 1,000? So again, I could sit here and do 2 plus 4 plus 6 plus 8 and work my way all the way up to 1,000. Or I can do this, 2 plus 4 plus 6. I notice that it's going up by adding 2s, so this will work. And then if I do the last 4 numbers, let's see, what would that be? So 994 plus 996 plus 998 plus 1,000. Okay, so I can do the same thing. My first number and my last number I can add together first. That adds up to 1,002. My next two, 4 and 998, add up to 1,002. Okay, those two together add up to 1,002. Those two together add up to 1,002. So I know I'm going to have 1,002. My question is, how many times am I going to have 1,002? So we don't want to add up all the numbers from 1,000. We want to add up only the even numbers. So that means that we have 500 numbers. Taking out all the odds, 500 numbers left. And then I'm going to pair them up. So I'm going to have 250 pairs of numbers, and each of those 250 pairs add up to 1,002. So all the even numbers from 1 to 1,000 are going to add up to whoops, sorry. $250,500. Okay, so our lesson for today is summation, adding up all the numbers in the sequence, and that's called a series. Okay, so here are our vocab. So a series is the sum of all the terms of a sequence. And if you look at example 4, instead of commas, you'll see plus signs. It's kind of like the same thing. The S sub n, the second vocab, that when you see that, just means the sum of the first n terms in a sequence. So if it was S sub n or S sub 9, that means add up the first 9 terms in the sequence. If it was S sub 100, that would mean add up the first 100 terms in the sequence. And then finally, that last funny symbol looks like a capital E. That is sigma. It's a Greek letter, sigma. And in math, sigma means summation. And that means to add up the indicated terms. Okay, so for example 1. This looks really funny, but it actually is a lot easier than it looks. I know it looks really bad. So sigma here, that means to add up. And what we're going to add up are certain terms. And it's going to say which terms to use. So n equals 1, that means we're going to start with that. And we're going to do all the terms up to 4. So do all up to 4. All right, now n's going to be our plug-in number. So this is telling you what to do with n. You're going to fill in 1 there. So I have to do all the ones from 1 to 4. So it's going to be 2 times the n number. So first it's going to be 2 times 1. And then we have to go all the way up to 4. So then we're going to do 2 times 2 minus 1. So then we're going to do 2 times 3. And then we're finally going to work our way up to the 4, which is 2 times 4. So what I have written in blue is all the n's. We're going to fill in from 1 all the way up to 4. So right now we're going to go ahead and put this and evaluate each one. So you can do this in your calculator, but 2 times 1 is 2. Take away 1 is 1. Actually, I'll do it in a different color. All right, 2 times 2 is 4. Take away 1 is 3. 2 times 3 is 6. Take away 1 is 5. And 2 times 4 is 8 minus 1 is 7. Now, we're still not done, because now we have to do the sigma part. Sigma means to add up. So this means that we're going to take all our answers, all of these green numbers, and we're going to add them up. So 1 plus 3 is 4, plus 5 is 9, plus 7 more is 16. And that is how you do summation, at least in with sigma notation. Okay, evaluate. So we're going to do now sigma, so that means add up all the ones starting with 3 and going up to 5. Okay, so there are our k's. Now we have 2 k's here. That means we have to fill in twice, just like you normally would any other time. If k is 3, you put them in for all the variables k. So now we're going to do 3 is the start number, and we're going to do it to the 3 minus 1 power. Then we're going to go up to 4, or up to 5. So then we're going to do 4 is k, so 4 to the 4 minus 1 power. And then we're going to do up to 5. So you're doing all the numbers in a row from the start number to the top number, which is your ending number. Okay, again, we can do this in our calculator if you want. So we're going to do 3 to the power 3 minus 1, which would be 3 squared or 9. So then we're going to do 4 to the power 4 minus 1, which is 4 to the third power is 64. And then we're going to do 5 up to the 5 minus 1 power, which is going to be 5 to the fourth, which is 625. All right, and then sigma means to add up. So now we're just going to add up all those numbers. And you get 698. Okay, and lastly, so this is looks a little different. There's a 4 out here. And remember, when something is connected to something else in math without an operation, it means that there is a times here. Now, also, you might see problems where there's an addition sign there, but this one is a times symbol. So what we're going to do first is we're going to do this first, and after we get the answer to that, we're going to multiply that answer with the 4 that's outside. Okay, so this means we're going to start with 0, fill in 0, then fill in 1, up to 2, up to final of 3. So we're going to fill in all from 0 to 3. So I'm going to write out all right, so first we're going to fill in 0, then we're going to fill in 1 for m, and we're going to fill in 2 for m, and then finally fill in 3 for m. Again, we can use our calculator or not. If you want to do it in your head, that's fine. Now, I'm going to give you a faster way to do this. If you use your calculator, you can actually get all of those values all at once, because all m minus 1 squared is a formula. So if I want to get them in a row like that, I can just plug it in using x. That's what I'm plugging into, and I just want to find all the values from 0 in my table up to 3. So when I plug in a 0, I know I'm going to get a 1. When I plug in a 1, I'm going to get a 0. So these are all your answers right here, 0 up to 3. So there is a really ingenious way to get these numbers rather than having to plug them in one at a time. Again, you could do them all by yourself if you want. All right, now the sigma part means add up. So now I'm going to add up all of these numbers. 1 plus 0 plus 1 is 2, plus 4 more is 6. Now that means that this part here, the sigma part, is 6. But don't forget, I still have the 4. So now we're going to have 4 times the 6 for the answer for the sigma, and our final answer is 24. So now I could have done this trick right here with the other problems as well. All right. Now there's one other thing I need to show you. Your calculator can actually do sigmas, but it's really important that you know how to do it the real way, because on a show your work problem, this is the work that you need to show. If it's multiple choice, then you can kind of do this, or you can use this as a way to check. There is a sigma key on your calculator. Let me go back to problem 1, and we'll do all 3 using the shortcut way. So the sigma symbol is on the 84 calculator. It's alpha window, and then it's number 2. On the Inspire, you have to go to the book symbol, the book symbol. Then you need to go to the second tab where you have that funny F, the second tab in. Oh, I'm sorry. It's the fourth one. It's where you have the boxes. Sorry. Press the book and then go to the 4 tab. And then you'll see the sigma in the middle of the second row. Okay, then all you have to do is fill in the boxes. So going back to problem 1, we have an N. Now you can use an X instead, or you can in fact use an N. It's up to you. That's a 1. Then you press up and fill in the top box, which is a 4. Now this is the most important part. Everything you see here, you really should fill into that box. I know that there's parentheses there, but trust me when I say that there are problems where if you mess this up, it's going to affect your answer. So we don't need them in here, but I'm just going to tell you, whatever you see, type in. So I see parentheses, I'm going to type it in. I also used an X, so I'm going to replace it with an X. And notice we got the same answer of 16. Okay, so now we'll do problem 2. So same thing, gonna get your sigma the same way you just got it. Again, it's a K, but I'm gonna use an X because it's just easier to use that. So this is 3 up to 5. Again, whatever I see, I'm gonna put in here. So now I have an X raised to the X minus 1 power. And there you go, I get my same answer of 698. All right, so now getting to the last problem. I can type it all in one step. So you're going to do 4. Now you don't have to do a times, but you can put a times if you want. If it's a plus, you definitely have to put a plus. So we're going to do 4 and then get your sigma. Again, I'm going to use an X. And this is where it really matters. If you mistakenly use those parentheses on the calculator to represent the parentheses in our problem, you would have it wrong. So I'm going to do it the wrong way right now. This is what a lot of students mistakenly do. I know it looks kind of the same, but this is totally different. Because you put the square on the outside of the parentheses, it's telling the calculator that you want to square the answer to the sigma. So you're going to get this answer, which we know the answer is 24. So that's the wrong way to do it. So don't do it that way. So what we have to do is we have to make sure everything we see gets put in those parentheses. So I see in there parentheses, so I'm going to do another parenthesis, X minus 1, parentheses squared. So this is going to, this means totally something different. This means to actually square the inside guy. And now we get our 24 that we thought it was. So just be careful on how you type it in. Okay, next problem. So express the sum. So now they want you to express the sum of these numbers using sigma notation. Okay, that means if we have to use sigma notation, that means we're going to use this E guy. All I have to do is figure out what number I'm going to start at, what number I have to end at, and then I have to put the formula in here. Now, when you're making up your own, you definitely want to make this guy be the first guy. So we're going to call that term 1. So all I have to do now is figure out what term is that guy on, and I have to figure out my formula. So if you can see the pattern, there might be more than one way to do this problem, but what I'm seeing on this problem is that I see that from this number to this number, I'm adding 9. And then from this number to that number, I'm adding another 9. So I can see that the pattern is adding 9s. Now, some of you guys might also notice that they are multiples of 9, like 9 times 1 and 9 times 2, 9 times 3, and you can most certainly use that pattern. So I'm just going to stick with the pattern I'm doing, because if you notice it's adding by 9, now you can use the arithmetic formula, which we've been using the last 2 days. So let's see, our first number is 9, and we're adding 9, and the number of 9s I need to add is n minus 1 of them. Again, if you were to expand that I just wrote out, you will actually get 9 times n. But it's up to you which way you want to do it. But I'm going to stick with this since it's more familiar to you. The only thing I have to do now is figure out what my top number is. And that's my ending number. But I don't know what it is. It's not 144. If I put a 144 here, that would mean that I have terms 1 up to 144. But it's definitely not going to be 144 terms since we're jumping by 9s. All right, now there's two ways to figure out what this n number is. We can do an algebra approach. The algebra approach would be 9 plus 9 times n minus 1 has to come out to equal 144. And this will get us to solve for n. Now I can do that, but again, let me just use my smarts here. I just showed you how if you ever want to get numbers in a row, you can use your equation in your table. So if I do it this way, my first term is my 9, my second term is my 18. So all I have to do then is figure out where 144 lands on. So this is a much easier way to find the answer. And 144 lands on the 16th number. So I now know that n is 16. And you would have gotten that answer if you also solved the one over there. Okay, so n is 16. And there is our first question. That is the representation of this series in sigma notation. So to evaluate it, I am definitely not going to want to do all the pieces out, so I will use the shortcut for this problem. So x1 up to term 16, and my formula is 9 plus 9 times x minus 1. And that means all of those numbers would add up to 1,224. Okay, so now that you learned about summations, we're now going to apply them to our arithmetic and geometric series. Okay, so if I have to find the sum of the series, 3 plus 23 plus 43 plus 63 plus 83, etc., I can do method 1. And method 1 is to actually list out all the terms and add them up all together. So I'm not going to do it that way, but on a test or a quiz or the Regents, you can most certainly do it that way. Method number 2 is I can write it using my new notation that we learned. We can do our sigma notation. So let's see. This one, and we can see the pattern. We can see that each number is going up by, oops, not 10, 20. So if I see that it's following one of my geometric or arithmetic ways, I can now use the formula method with my sigma. So sigma, my first number when we do our own is going to be always at 1. And they did in fact tell you, oh no, they didn't tell you the number of numbers, but I can count. This one's actually easier than the one we just did because I can actually count 1, 2, 3, 4, 5, 6, 7, 8, 9. I can actually see that there are 12 numbers. So there are 12 numbers, and all I have to do now is put my formula in here, and that's the formula you learned for the last 2 days. So this is going up by 20s for adding. So you're starting at 3, you're adding 20, and minus 1 times. So that's it. It's kind of like doing what we just did last 2 days, but adding a little bit more. The sigma is the only new notation. Okay, my formula, I'm going to do exactly what I have written in red. So those are all going to add up to 1,356. Now there is a third approach, and that actually goes along with the very first problem we did, where we paired up numbers. There is a formula, And the formula is actually given to you on the Regents reference sheet. So this is method 3. Now to explain the formula and why I gave you the problem 1 to begin with, this right here represents if I pair up the numbers. So this is the first and this is the last number. That was what I did originally when I said add up the numbers from 1 to 100. And then the other part of the formula is how many pairs you're going to have. So this should make sense then. N is the number of numbers, divided by 2 is how many pairs, and the pairs all add up to, if I pair up the first and last, they'll all be the same value for those pairs. Okay, so I'm going to write down my formula. Now we are adding up 12 numbers. So it would be like S of 12. I'll first start off with the formula though. Again, you don't have to memorize this. You will be given this each and every time. So you're going to add up the first 12 numbers. So this is 12. The first number is 3. And A sub n, this is your last number because it's 12. So now this means it's the 12th number. So that's going to be 223. Now sometimes it's not going to be easy. You might have to actually figure it out if they don't give it to you, and then divide it by 2. So if I do it that way, I get the same answer. Okay, so those are your 3 options. So we're going to do this with one more arithmetic, and then we'll go to geometric, which is a different formula. That one's a little bit harder. All right, so again, if I want to find out the first 17 terms, I can most definitely list all 17 out and then add them individually. Most certainly can do that. Okay, but I'm going to do it the other 2 ways. So again, if I want to do it the sigma way, I have the first one. That's the first one. And again, they made it easy. They told me there's going to be 17 numbers, but it might happen like the last problem we did on the front page where you had to actually figure out what number you're on. So please be careful of this number. If they don't give it to you, you have to find it. So there are going to be 17 total numbers. All I have to do now is put my formula in here. And this one I can see we're adding by 6. So it's 5 plus 6 times n minus 1. Okay, now most of you guys maybe will prefer this method, but the formula way is kind of nice because you will be given that on the, like I said, on the Regents. Okay, so that's going to add up to 901. Okay, in order to use my formula way to show you what that would look like, so it would be S of sub, well, 17. So I'm trying to find the sum of the first 17 numbers. So I have 17 numbers. A1 means the first term. But here's the problem with this formula. I have to actually find the nth number, which is the 17th number. So you actually have to find the formula in order to find the 17th number. So if you have the formula, then you actually could do the sigma way. So the sigma way is probably easier for this type of problem. But the 17th number would be, let's see, we're starting at 5, and we're going to add 6 16 times. So the 17th number would end up being 101. And now I can see how many pairs I have and what the pairs add up to. And again, that adds up to 9. 101. Okay, we're going to just do one last type, and that's our geometric. Virtually, this is about basically the same, except the formulas, number 3 is different. All right, so this time it's going to be a geometric, and you can tell because the numbers are definitely getting, the differences are not the same. It's definitely getting bigger than smaller. So if we want to find the sum of these numbers, again, we could just add them up on the calculator. Number 2, we can again do our sigma notation. So n, we always start off with the first number. I can actually count. There are 10 numbers, so we're going to go on the first 10 terms, and all I have to do is fill in my formula. So it's starting at 1024, and I'm multiplying to the n minus 1 power. So all I have to do now is figure out what am I multiplying by. So to figure out my common ratio, we just take a number and divide it by the term before it. So 512 divided by 1024 is a half. Okay, so I have all the information I need. I can now find the sum of all of these numbers without typing them all in. Okay, remember, everything is inside the original set of parentheses. So 2046. Okay, now the third way. You were also given this formula on the formula card. So it's at the bottom, S of n, that means the sum of the numbers is equal to this formula. A1, the first number, times 1 minus r, which is the rate, raised to the number of numbers, all over 1 minus r. Okay, so if you do it this way, that means that we have, 10 numbers. So S of 10 would be the sum of the first 10. The first one right here, that was 1024. 1 minus, now you have to actually figure out the rate. So we already did in the previous step, but you would have to do it for this as well. And it's 1/2. And there are 10 numbers, so raised to the 10th power. Now that 10 is only going on the half, not on the outside. And then it's 1 over, 1/2, sorry. Putting that in our calculator, you will actually see that it will come up with the same answer. Okay, same answer. Okay, last problem. We'll try one more of these. So, again, find the first 10 terms. So if you notice, we're timesing by 3. So if you want to continue the pattern and list out all 10 numbers, and add them up, you can most certainly do that. All right, we'll try the sigma way and the formula way. Sigma, we're going to start with the first. Again, really easy. They told me there are going to be 10 terms. Not always that easy. You may have to find out what term number you're at, but this is going to be 10 terms. Now I have to do the formula. We're starting at 5. We're timesing by 3, n minus 1 times. So these will all add up to 147,620. Okay, doing our formula way, I'll write it again. Okay, S sub, we have 10 numbers. So it's the sum of the first 10. This means the first term, which is 5. 1 minus, okay, I have to figure out the rate, and we can see it's 3. And we raise it to the 10th power, all over 1 minus 3. And again, same answer. So you can choose whatever method you like better.